Hello everyone. In this video we're going to be talking about double discounts and how they can be applied to help us solve word problems. Alright, so we're going to jump right into one here. So we're told that we buy a new camera for $178.50. It's on sale for 15% off. And let's assume you get another 33% off on top of that. So these are being applied consecutively, meaning we're not treating this as 48% off. We're treating it as 15% off, calculated, and then 33% off that kind of middle discounted price. So what we're going to do is basically solve it first with two proportions. Then we'll talk about some other options as well. So we're going to set it up by taking 15% off of 178.50, which means in our proportion we're really using 85 over 100. The percent that we're paying is 85%, since it is 15% off. Now this will give us around $151, if you solve it correctly, cross multiply, $151.73. So I'm going to do a second proportion. Feel free, you could pause if you want to jot down the notes. Notice towards the very bottom here, it says the second time you do the proportion, that adjusted price, whatever we found from step one, is actually going to be treated like our original price. So we're treating this like an original, and then we're taking a 33% off discount. In other words, we're paying 67%. Now if we solve this, we'll get approximately $101.66. So this is how you solve it, kind of showing your work and the proportion and all that stuff. Does the order actually matter here? Does it matter if the cashier were to put in the 15% first or the 33% first? The best way to think of it is with equations, when we just multiply. So we really took 178.50, multiplied it by 0.85, and then we took that result and multiplied it by 0.67. So this is really what we just did in short. And it should work out to the same answer. So would it matter if we switch the order? If you look at that equation we just wrote, or expression I should say, imagine switching the 67 and the 85. The commutative property tells me I'm allowed to do that. I suppose I don't need the parentheses here. So if I were to just switch those out, parentheses don't serve any purpose. If I were to just switch these two, okay, obviously I'm allowed to do that. The commutative property of multiplication tells me I am. So if you take 178.5 and multiply it by 0.67, or if you were to start this proportion over again and start with the 67 over 100 up here, you would actually get the same exact final answer. Now your answer in the middle, which doesn't really have a name like that middle discounted price, is going to be different, obviously, but your final answer should be the exact same. So with double discounts, just be aware that you can switch the order. Right? A question might ask you or prompt you to do them in a specific order anyway, but be aware that the order does not play a purpose, and that's all related back to the commutative property of multiplication. Also be aware of how to use equations. As we saw with the combination lesson, multiplying by the decimals are sometimes quicker for these problems that require 2 or 3 different proportions in one. Okay, and in this example we're going to be taking a look at finding an original price. We've seen this after given a discounted price, but now after given 2 discounted amounts, what the original is. So this is working backwards twice. We're going to start by setting up a proportion where we're basically undoing that second coupon. We're literally working backwards, so we want to undo the 25% that was taken off. So when we paid $57, that represented us paying 75% of some amount. Right? 75 is the complement. If we were to add the 25% there, that would add up to a full 100%. Now when we cross multiply here, we're going to get 5,700 equals 75x. As we've seen too, just on the last slide, I'm kind of working backwards. So I'm kind of doing this literally. I'm going to undo the second one and then the first one. Obviously we've seen the order is not important. So I could have started this by undoing the 5% off as well. And we should get 76. So that's nothing right now. That's just kind of our in-between, that price that was in between the two coupons, because now I want to undo the second coupon of 5% off. So I'm going to be using the 76 here as my new numerator. And how can I undo 5%? Well, basically think of it as when we paid, or we didn't pay $76, but $76 right now represents 95% of something. Okay, that adjusted price represents an adjusted percent of 95%. When we cross multiply here, we'll get 95x equals 7,600. When we divide by 95, we should get x equals $80 for our original price. And you could work forwards now if you want to double check. Take 5% of 80, and then take 5% off of 80, or 95% of 80, and then take 25% off of that price, or that amount, or 75% of that number, and you should get 57. So basically, we've seen finding original. This is just doing it twice and carrying that in-between answer. Like 76, we don't really have a name for it. It's the middle price, I guess. But carrying that over to your second proportion is important. Notice we didn't use 57. We're undoing the 76. We're undoing the 5% for that. Now, what would this look like as an equation? Might be a little bit simpler. Basically, think of it as we got 57 as an answer. So obviously, we're finding a whole amount here. If we think of our original price as x, we first took 95% of x, or basically multiplied it by 0.95. And then we took 75% of that. And again, these are the complements. Because they were percents off, this is the percent that we have remaining to pay. Okay? If we use the associative property here and multiply the 0.75 and 0.95 together, multiply those two decimals together, you'll get 0.7125. So imagine if I were to drop the parentheses out and multiply the two decimals, equals 57. And now if I divide both sides by 0.7125, let's do 57 divided by 0.7125, we get 80 as well. So this is what it would look like as an equation. So even though it's a double move, just like with double discounts, we can still translate to decimals or equations and solve that way as well. So this is double discounts, working both ways, applying double discounts, and then kind of working backwards to find an original amount. We'll talk more about this in class on Thursday. You're going to try your best in practice with this concept tomorrow in class on Wednesday. Please feel free to write down any questions you have about this topic, and I'll try to use that when I come back to class on Thursday. Thank you all for watching, and have a great day.